Hey guys, AP here, and today we are going to be adding uniform variables into our code. So what uniform variables does is it basically allows us to interact with the shader program from our main or any class for that matter. So instead of having to set variables in here, which we don't want, we just want to leave these alone and just change it in here. We can add uniform variables, which is what we already added here, but for textures. But it takes in the attribute from, where's that attribute? From our model class. So we're going to be adding uniforms for multiple like floats, vectors, and of course matrices. So we can actually have 3D translations, rotations, and scaling. Because at right now we do not have that. We just have a 2D textured image, as you can see here. Wrong way. Here we go. I swear it's just working. Hold on. Okay, fixed it. It was just something wrong with my vertex shader. So basically what we have is a 2D rectangle with an image on it. What we want to do next episode is we want to make this a 3D flat plane so we can like rotate it in 3D space. So, but first we have to create uniforms for that. So let's go to our shader class because all of this is going to be done in the shaders. We'll be changing none of this code up here. And we're going to create another abstract method. So protected abstract void get all uniforms, which is basically going to load all the uniform variables from our basic shader class over here. So to do that, we have to create another method like this where we have a singular one instead of multiple. So we do protected void get uniform, and that's going to take in protected. It's actually going to return an int, and it's going to take in the name of the uniform. So we're going to call that name. Anyways, so what we have to do here is we have to return integer, which is going to be gl20.gl get uniform location, and program ID, which we already have here, and the name, which is name, and a semicolon. So basically what we have here is we have something that can be that we can get the name from a uniform in here, and it returns int in here. So next, what we got to do is with that int, which is our location, we need to load a value in there. So we're going to create 4 methods, which they're all going to be pretty similar, but the matrix loading is going to be a bit different. So it's going to be void load float uniform, and that's going to take in the location, which is an int, and value, which is obviously a float because it's a float uniform. So float value. There we go. And what this does is gl20.gl uniform 1f, which is one float value. And this function puts the value into the location that we provide, so location value. So I'm just going to copy and paste this again, and we're going to change the value from float to int, and then float to vector 3f, which is 3 vector 3 float values, and matrix, which is 16 float values. So that's going to be a bit different, but for the int, it's basically almost the same thing. So instead of 1f, it's 1I for int, f for float, I for int. You get it? And load int uniform. Now here we're going to say load vector uniform, and it's going to take in a vector 3f, and let's import that. Hold on. Sorry, mosquito was in here. Anyways, so let's import that. There, that one. And instead of 1f, it's going to be 3f, but it doesn't take in a vector. It has to take in 3 different float values. So location, and since a vector is usually a position, it just assumes it's x. So x, value y, and value z. So we're almost done. We just have to get to the matrix one, which is a bit different. So first it takes in matrix 4f. And it doesn't do this, it does .gl uniform matrix for FV. And it has 3 values. It takes in a location, which we have. Transpose is whether we want to transpose it or what. Not. We really don't, so we're going to set that to false. And value is what we have up here, but this is actually a bit different. So a matrix is a matrix for f. So we have to convert this into a float buffer because it doesn't, the GL uniforms don't take in matrices. So we need to create a float buffer. It's going to be called buffer, and we're going to use the buffer util class to create it for us. And then create float buffer. The capacity is always going to be 16 because a 4x4 matrix is 16 values. So, and then import float buffer. And then we need to put the matrix into the buffer, but you don't use buffer.put. You have to do value.get, and then the buffer you want, which is buffer. And now we do buffer.flip, because like I said in previous tutorials, GL likes it flipped. I don't know why, and I haven't looked it up yet, but I probably will. So now we can put in the buffer instead of value, and it should work. So we should have all our shader code done, and so let's go in the basic shader. Let's implement the method, get all uniforms, and let's get writing some code. So in your vertex shader, you can do anything like the color offset, like the X offset, the Y offset. What I'm going to do is I'm going to do scale because it's very simple to implement. So what I'm going to do is I'm going to take in a uniform float scale. So now, since we now taken scale, we need to use it somewhere down here. I'm going to multiply it by the position, which means that it gets scaled appropriately based on what you put in as your uniform. So now that we have our scale, we need to go into basic shader and actually load that into our main class. So we need to create a integer called scale location to hold our location of the scale uniform variable. So with this get all uniforms, we need to do scale location is equal to super dot get uniform and the name, which is scaled. So now we have the location of scale in our vertex shader. It can be in the fragment shader too, but we're just putting in the vertex because that changes the position. And okay, now we need to create another method that actually loads a value into our scale location, which is basically where our scale uniform is in here. So we're going to create a public method called void load scale, and it's going to take in a float number because we need to load this number that we're taking in into the scale location. So we're going to use super.load float uniform, and we need to call this scale location and value. Also, change this to matrix uniform. I forgot to do that, so just change that to matrix. And so now all our shader code, all of the code should be done. And so all we need to do is add one line to here, and we can appropriately scale our image. So right under the shader.bind, we're going to add shader.load scale, and let's just do 0.5 1.5f, half the size of it. So error exists. Let's see. Oh, S, crap. Okay, there we go. So now our image should be half the size as it was, and it is. And we can also make it the entire screen by just calling, instead of saying a half, we just say 2, which, yeah, should make the entire screen this image. So yeah, that's what uniforms are. They allow the Java code to access the shader code. And we're going to be using this next tutorial to add some projection matrices, and for the next 3 tutorials we're going to go over the 3 matrix that makes 3D work on computer graphics. So yeah, this is it for the tutorial, and hope you enjoyed it, and I'll see you next time. Bye!